Are there some people here that expect this talk to be about Git?
Yes.
I am not going to talk about Git. So if you expect to learn something about Git, this is the wrong room and this is your last chance to find another good talk. Let's start. Okay. You're at the right spot. So for the people who don't know me, I'm book, I'm French, I'm wearing pink, so that people can recognize me, and I don't have to be brilliant for that. Okay, let's start. How far does it have to be? I have a big project that actually the idea came during the Go QA Academy in Vienna in 2009. The problem is that was kind of a based on Git, but it's top secret. This is a new remote, as you can imagine. And basically, this means I need to control Git from Perl and have full control of the repository and full control of the objects in the database. So basically, this is a way for me to show my Git through. But there is no libgit, so it's not, I mean, I don't know XS anyway, so I couldn't have done that. But there is no libgit, so any module in Perl that will do things with Git has to be a command line wrapper. And that's one of the limitations of Git that everybody complains about, but it's not going to change. There is a libgit project, but it's not done by the Git people, so the chances of success are, I don't know. Anyway, so a quick question for the audience. I was told yesterday I have to interact with the audience so they feel included. So this is the French guy for that same show you have in your country. So, who wants to call a friend? So the answer is there are 132 Git commands. And actually there are 128 non-deprecated Git commands. There are, I need to move this so I can see what I'm saying. There are many categories. So there are 37 Porcelain common, among which only one common, 17 so-and-so, 15 blah, 9 others, and so on. And that adds up to 100 and one of the two numbers I gave. But there are two main types of comments. One of them is the Porcelain, which are high-level, user-facing, and there are 21 of them, which are those, which you probably use in your daily use. And the other type of comments is the plumbing. They are low-level, they are repository-facing, and they are meant to talk to other programs. So their output is guaranteed not to change, which is very nice. And this is some of them, some of the interesting ones, and there are 90 others. And there's still little space in that margin to write them. I don't know yet. I mean, when I started that project, it was like a great idea and no code, and I wasn't even sure how I would do it. I just knew it should be possible. So I didn't know which Git comments I would need. Yeah, I should point it at the machine. And I didn't want to limit myself. So I listed my basic needs, which were I want to be able to call any Git command. I want the module to be available on cpan, and I don't want any of the directory issues like what happens if you start your script in a directory and then you change the directory and the Git wrapper expect you to be in another directory or fucks up some way because of a change here it did or it didn't do or it should have done. So, of course, I first looked for prior art. I found 3 modules. The first one is git.pm from the git.git repository. And I'm not going to bore you through the appearing bullets. So, with it I was able to call any git command, but it had a complex interface. There are like, I don't know, 8 or 10 ways to call a git command depending on what you want to use. If you want to give it input, read the output, get the errors in that way or that other way. The interface is not even consistent. When you want to send something on standard input and also read from standard output, which is what they call a bi-directional command, the interface is different from the others, the other methods, so it's really annoying. It is not on CPAN because it's included with Git, which is opening all kinds of problems, like it's with your system Perl, but not the Perl you've compiled to work in your project. It does the change of directory before running the command, so it knows where it should be, and it goes there and then does its stuff, and that's done in an external process, so it doesn't impact your own program, which is nice. Except when it doesn't do that. Actually, one of the problems is fixed thanks to Brian, I think, who has put git.pm on CPAN. But still. The other module is git class, which is using Moose, on which I have no opinion. It only has roles for Porcelain comments, so the 21 comments that I showed at the beginning. It can anyway call any git command. It is available on CPAN, but it does its change of directory when you create the object. Or at least it did last time when I checked. And then there is git wrapper that can call any git command, but that cannot write on standard input, so you cannot interact with all the git commands. It is on CPAN, and it also has changed their issues. So in summary, all of them have pluses, but none of them have all pluses. So, right, which is what this talk is about. So, I find that Git and Perl have a lot in common. Mostly there's more than one way to do it, and there really is more than one way to do anything in Git. The other thing is, for my module, I wanted to be true to the Perl model, and so for Git repository, I wanted the Porcelain to be easy and the plumbing to be easy too. So I want it to be simple, and that starts with a simple interface, different from git.pm. So a Git repository object is just context for wherever your Git repo lives, wherever the working directory lives. It's basically a hash with two keys. So that's the context for running Git commands, which means you create a new context like this, called new on the method. And of course, there are a number of options to tell it where your Git dir is, where your work tree is. You can pass a few options that will be used for every option that I will talk about later. And comments are, so you take your context object there, that we created in the previous slide. You tell it which command you want to run. You tell it which command you want to run. And then all the arguments of what would be your command line if you were using Git on the command line as strings, and the options as a hash. And that's one of the cases where I know what I want to send on standard input, so I just put it there and it will be printed. And that returns the output. And again, so I create a commit like this. I give it the tree ID, use commit tree, send the log message, and it gives me back the commit ID. And then I can tag that ID with a tag name. So I use the update ref plumbing command, give it the name of the reference, and point it to the commit ID. So it's, of course, it's longer than writing it on the command line, but it's very close to what the command line looks like. If you don't have a context, for example, you're writing a command line tool based on Git that does magic stuff on your Git repo, and it should work in any Git repo, so you don't really need to tell it, this is the directory where I want you to work. It should work like Git. So if you use the class, it provides the default context, which means basically run Git where you are, and it will find its stuff by itself. So instead of the $R, we're using the class name, and that will find whatever we need to run the exact same command. So the general interface is also simple because there are only very few methods. I've shown you the new method already. And there are two others, which are run this command and give me the results. In scalar context, it gives you the whole output, and in list context, it gives you the lines and helpfully chunks the end of the lines for you. And if you want to go deeper and actually fiddle with the file handles to that Git command you're running, you can ask Git repository to give you a command object, which is of the class Git repository command. And so this is the command object. So it's time to talk about Git repository command, which is the workhorse of Git repository, because the module itself is just a hash with a configuration. So you normally don't have to interact with Git repository commands, but that's what calls Git itself. So the interface is new. The list of the commands, so first parameters, well, all the options to your Git command line. So add command here will be commit, whatever. You can pass it a Git repository object for context. So $R here is a Git repository object, and you will perform that command on that repo. And you can even pass it options as a hash. And these options will be run only on that command. And so once you've got this command object, you can do stuff with it. So you get it's basically a hash. I have no opinion on moves because I don't need it. I'm too stupid to do complex stuff. So this is a right handle that's open to the input of the Git command. The other ones are the output and error of that Git command, the PID of the sub-process. When you're done talking to that process, you can close everything, and once it's dead, you can, well, once the forked command is dead, you can get some information about the exit status, the signal, the call, and so on. And I guess this is the third time I gave this presentation, and of course it has changed in between. But when I gave it the first time at OSDC in France, Alexis from Dancer asked me, why isn't this a CBAM module? Actually, he asked it in French, and that felt like a very good idea, so I did it. So now, this, what I showed, the call new on a command line and get an object to fiddle with the input-output is system command and CPAN. Someone has also done another module called syscommand, but that's based on the older Git repository command, so it has the same bugs as the old one and a few different features. And the new one has new bugs and different features as well. So it's big. Anyway. So system command is now the module that handles the options. And the options can be of a number of types. So, sorry, I'm going to talk back again about Git repository command, which is a subclass of system command. So it does, all of the work is done by system command, but it's adding a few things, like being able to not have to give the path to the Git command. You can give the path to the Git command that you want to run. So if you have 10 Perls and 10 Gits installed on your system, you can like run the same thing over using different Git binaries and things like that. I personally have all the Git published versions since 1.6.0, I think, which is about 240 something. So all the options are the Git binary, the directory where you want your command to be run. So it's not really the working dir, it's more like it's the working dir in the Unix sense. And you can override the environment by giving a few extra options. So usually these are options, these are environment variables that Git understands. And the fourth option is the input. You can give it the string of input that you want to send it. Yeah. So the options can be given anywhere. And when I say anywhere, I mean anywhere. You can give them at the object creation as part of the new command, and then they become global options for your repository, so they will be added to every Git command that you're running. So that could be a place to say which Git binary you want to use. You can give them when you run a single command, so like local options, for example, to tell, hey, for this commit, it's that user that did the commit. And you can also give them to Git repository command itself. So when you call the command instead of the run, again you can give the options. And actually you can give more than one set of options, and they are merged in there are only 4 types of options, so it's not too difficult to do a little bit of extra work so that it works correctly. So that means if you had options with your new, and then you pack another set of options, the last one in the list will take precedence. You can delete environment variables by just setting them to undef. If you set them to the empty string, the environment variable will exist, but it will be empty. And yeah, okay, so that's it. And someone asked me to actually change the Git binary to be something more interesting. So now you can do this, and instead of passing a string that is the path to a Git command you want to run, you can pass an array. And so the actual command that will be run is this. Right now I don't remember how it's done, but it works. And what that means, if you do this at the time of the creation of your repository object, every command will be run in a sudo environment. So it's like fire and forget. You don't have to think about it again at the beginning of your program, and don't think about it. One issue with, one good thing with Git is that it evolves rapidly. So there are new commands. For example, git init was added in 1.5.0. Before you had to do git init-db. And there are also new options all the time. So git init directory was added in 1.6.5, which means very quickly when you are trying to do some serious magic with Git, you will need to know which Git you're talking to. So even though I didn't want to have too many functions, I had to add them. So this gives you the version of the Git you're running. Of course, you can give it options. So you can ask the version of the specific Git just to know. It works with Lyon.pm, what I said, it works with options. And there are a bunch of version comparison operators. So you can actually compare the version of the Git you're running with any version that you want. So it's comparison with a single argument. So here's an example that you can read and I can't. So yeah, the example here is, I know that Git, because I test on 200 Git, I know that git add dot fails on an empty repository between 1.5.3 and 1.6.3.2, which means I have to wrap this in an eval block, just in case I would be running one of those. And I also know that git status actually has a Porcelain option, which means it's going to be giving me machine-readable output that I know won't change in the future. Oops. And so I have to do this. If the version is lower than 1.7.0, I fall back to this and matching the output. And luckily, older versions of Git don't have localization, so that kind of stuff works. And when Git gets localization, it will be a later version, so this will guarantee to work too. So that's an example of using version comparison in your Git programs. This is an actual subroutine from a project, the project I was talking about. If you want to learn more, there is a tutorial in the distribution with a lot of examples on how to do a number of things. This is basically every time somebody asks me a question, I put it there. I put the answer there, and the question too. And of course, if you are testing modules that need Git, for example, if you're testing Git repository, which I do a lot, you need a module to test Git stuff. So test Git provides two functions. One of them will skip if you don't have a Git installed or if you cannot find a Git. Of course, you can give it options, so you can tell it, try, I don't know, you could have a list of possible Git positions and just send them to as options and then find out which one is the one you want to use for your test, something like that, whatever. And you can also tell it which minimum version you need. So it not only has to have Git, but also to have at least that one. And I think, and of course, if you are going to do test with Git, you need a test repository. And this function takes a number of complex parameters which I never use. And this basically creates a temporary repository in a temporary directory and gives you back a Git repository object. So you can do stuff and it will be deleted, the directory itself will be deleted when the Git repository object goes out of scope, so it's clean. And I think I have time for a live demo, unless you have questions. There is a mic there, or I can give it to you.
Just a very short one. Did you look in VCE?
VCE?
Yeah.
What is it?
Like a V.
Yeah? VCI?
Yeah, VCI, sorry.
No. I think I did a cpan search with Git 1.5 years ago, and I didn't find anything. Yeah, I know what it is, but I didn't check. I didn't check if there was a Git binding.
Now it is.
Okay. Maybe it didn't exist at the time, or no other questions? Okay. So time to stop following Damien's advice and do a live demo. No break. No, it's a real live demo. I deleted everything before. I hope I didn't delete too much. So I have two demos actually. So it all depends if you like trees or fractals. Let me show you the trees first. So basically Git, the nice thing about Git is it's all about directed acyclic graphs, which means trees. Well, a bit more than trees. And so you can do graphs using Git. That's cool. And once I was in Amsterdam with one of my colleagues who's probably here, yes, and we started talking about fractals, and fractals that are actually graphs because you build them iteratively. And I said, we can do it in Git. So the first attempt was to do the Sierpinski triangle. So you got a commit, a child, another child, and you merge them, you got a triangle, then you do that again, and again with bigger triangles and so on. We tried really hard and couldn't get it to work. So, you can't read this, of course. So I have a few comments in Git. I need at least Git 1.6.5. I can create nodes. I change the date of the commits. And I start with an empty tree, which has this magic number you should know by heart. So let's run it. I'm going to do create a directory. Whatever. So step 0. This is going amazing. Wrong direction. Okay, so we're going to be blown away. Yeah, like I said. Sorry? What I say, this is my demo, I failed alone. Okay. Yeah. First iteration. It works. Okay, let's do it a bit more quickly. I hit you. Yeah. Yeah, next time it's going to be fake. So. Yeah, I have that, but I stupidly put some defaults in my script. Yeah, what you said. So. Have you noticed, for the oldest among you, how the computer always kills my presentation? I don't remember the options for Git. Okay, so luckily I have a script that is smarter than me and does all that stuff. notice it takes longer because it's fractal, so it explodes. And it's going to step 6, which takes a long time. Sorry? It would if system command worked on Windows. So I delegated the problem to someone else who is me. The fundamental issue is that file handles are really, really different in Windows and in Unix. And of course, I did that from the Unix perspective. So, sorry? I think on Sigwin it should work. Yeah, it's in this. Okay, so let's. Step 2. If you look closely, so get closer, please. This is the second iteration. So you've got 3 triangles connected in the right way. It doesn't look like it's correct, but it is. And of course, I have another program somewhere else, which is bound to fail if I run in the right place. Like I said. Anyway, so since it's a graph, I can use the Git output to. Is Damien here? You will tell him he was right. Okay, let's do the other demo. I can fail twice. And anyway, these Git fractals, you do Git fractals on Google, and you will find a website with all the explanations and the code, and I assure you it worked the last 2 times I did the demo. So this is another Git hack. It's still trees, and it happens that when you have 2 parents and they have a child, it's like they merge to create a new thing. This is actually what happened. So we could use the trees in Git to represent a family tree, and each of the 3 objects in the Git repo would contain all the data associated with that person. And that would be very space efficient, because if you have a photo with 10 people, it could be in all of those 10 people's directory. And of course, Git being Git, it's stored only once. I have 6 minutes. And it was fun to do anyway. So I did another command line, another script. Yeah, well, I don't think, even if it's readable, it's not going to be understandable, so I don't think you really care. That was done during, the idea came up during an Amsterdam.pm meeting. I think Amsterdam has an effect on me. And so while Liz was doing a talk, which I didn't listen to, I wrote that to basically have a command line tool to create commits with fathers and mothers and children. And of course, if you know Git, you know what the problem is. If you want to change the past, you have to rewrite the whole history. And this script does that when you add parents to someone who already exists. So I have scripted it so it cannot fail. So this is my family. So bunch of setup. I have to run this in the right directory. So on the top, this is me, my birthday. Oh, there, by the way, each commit in Git has 2 dates, the author date and the committer date. So you could say that the author date is the birth date and the committer date is the date you committed suicide or whatever. So me, my brother, my wife, my daughters, and so on. Let's run it. I have to read the code. Maybe I need to do this. I don't know. I'm completely lost. I'm going to break down in 30 seconds, especially the wrong spelling. Exist. Never, never do a live demo. Stuff happens. No, it doesn't. I just create files that are broken. That's how I fail. Let's try again. Oh, yes, of course. Pay attention. Here, this number. Remember it, it's me. I know I have parents, so I have changed. That's because the commit that represents me is now different. I also put my brother's wife and other people, and of course you can do that. Add more people to your family, and this is completely unreadable as expected. So let me start again. I like saying. So that was the first Git tree, and it's shown with that module that does graphs. So then I run it again, I have people, and it changes more people to my family, and again, there are more people, and so on. And then, because it worked so well during the French Perl workshop, someone asked, what if your grandmother cheated with your granduncle? My first answer was, you're sick. But then, of course, I changed history. So let's do it again till the end. Yeah. So, this is my grandmother, this is my grand-uncle. And so someone asked, what if they had, you know, you did that.